Now let's take a look at more examples on area under and between curves. Now let's look at this graph. We're asked to evaluate the area under and between the curves, and we have three shaded areas. We have A1, we have A2, and we have A3. Now A1 is what we are familiar with. A3 is also what we are familiar with because it is under the curve. But when it is below x-axis, okay, the result will just be minus. So we can say that A1 is the integral from a to b of f of x dx. Likewise, A3 is integral of c, the lower limit of A3 is c to d of f of x dx. And A2 is integral of b to c of f of x dx. However, because A2 is below x-axis, we will have a negative sign. So the total area, the total shaded area, is equal to A1 plus A2 plus A3. So we'll be applying this principle in this example we are going to consider now. So we are asked to determine the area between the curves. Between the curve y is equals to x cubed minus 2x squared minus x squared and the x-axis. Now when we have a question like this that determine the area between the curve this and the x-axis, therefore we are saying, and we will notice that in this case we don't have any value of x. That means we are saying from x is equals to this to x is equals to that. So we have to determine the point of intersection of the curve and x-axis. And at the x-axis, for this case, we are saying that y is equals to 0. Therefore, we are going to simplify the equation of x cubed minus 2x squared minus 8x to be equals to 0. Now, when we simplify this, we will have x into x plus 2 and x minus 4. Therefore, when y is equals to 0, we have three values. X is equals to 0, x is equals to minus 2, and x is equals to 4. Now, let's sketch the graph of x cubed minus 2x squared minus 8x. Now, sketching the graph of this, we have something similar to this. So I'll ask to evaluate this area coupled with this area. So the point here is minus 2, 0, and the point here is 4. This is y is equals to f of x. Okay, and the f of x is x cubed. Okay, x cubed minus 2x squared minus 8x. So now to evaluate this area, now we have A1 and we also have A2. Okay, so the first thing to do is to evaluate A1. A1 is integral from minus 2 to 0. Note that it is above the x-axis, so it is positive, of f of x dx, and f of x is what? X cubed minus 2x squared minus 8x with dx. So when we simplify this will give us integrating, we have to integrate x cube, and we'll have x4 over 4 minus 2x cube over 3 minus 8x squared over 2. Limit from -2 to 0. And simplifying this further, we will have our answer, final answer, to give us 6 2 over 3 square units. And now let us simplify A2. A2 is integration from 0 to 4 of x cubed minus 2x squared minus 8x dx. And now you notice that A2 is below x-axis, therefore it will have a negative sign here. So simplifying this, then we have to integrate, and this will give us x raised to the power 4 over 4 minus 2x cubed over 3 minus 8x squared over 2. And we are integrating from 4 to 0, noting that there is a negative sign applied there. So when we simplify this, we will have 42 2 raised to the power 3 square units. Now we can see here that our total area is the summation of areas. That is A1 plus A2 plus A3. And in this case, we just have A1 and A2. So our total area is equal to A1 plus A2. And this will give us 6 2 over 3 plus 42 2 over 3. And our final answer will be 49 1 over 3 square units. Now let's take another example on area between the curves. We are asked to determine the area enclosed between two curves. One is y is equals to x squared plus 1, and the other is y is equals to 7 minus x. Now to solve this, we are going to look at the point of intersection between the two curves. Okay, so that means we are going to equating the two y values. So we have x squared plus 1 to be equated to 7 minus x. This will enable us to find the point of intersection. So let's simplify this. We have x squared minus plus x minus 6 will be equals to 0. And this will give us x minus 2 and x plus 3 to be equals to 0, for which x is equals to 2 and x is equals to minus 3. So let's have a brief sketch of both y is equals to x squared plus 1 and y is equals to 7 minus x. So let's sketch them, and we can see that x squared minus 1 is similar to this, and 7 minus x is similar to this. Therefore, this point here is minus 3, and this point here is 2. This is the graph of y is equals to x squared plus 1, and this is the graph of y is equals to 7 minus x. And we are asked to evaluate the area between the two curves. Now the question is which is above and which is below. We can say that this 7 minus x is superior to x squared plus 1. Therefore, the shaded area will be the integral from minus 3 to 2 of 7 minus x minus x squared plus 1 dx. Therefore, we simplify further to give minus 3 to 2 and simplify what is in the denominator. We have 6 minus x squared dx. Then we have to integrate, and this will give us 6x minus x squared over 2 minus x cubed over 3. Limits from minus 3 to 2. So we substitute our upper limit and lower limits. So we give us 6 into 2 minus 2 squared over 2 minus 2 raised to power 3 over 3. And we subtract from the lower limit 6 into minus 3 minus 3 squared over 2 and minus into minus 3 cubed over 3. Therefore, simplifying this, we have it to give us 7 1 over 3 minus 13 1 over 2. And in conclusion, our final answer will give us 25 over 6 square units. Now we have been able to evaluate area under the curve and area between the curves. Let's take a look at simplifying the mean value and also the RMS value, that is the root mean square value.